Welcome to video 2.4C, double reflection across parallel lines. So just to let you know, there's two exciting things to come. A double reflection across parallel lines, and then later on a double reflection across intersecting lines. So this is the first of the two exciting things. All right, so we've got example 2A. Reflect triangle ABC across line M, and then reflect that image across line N and make an observation and fill in the blanks below. Okay, so again, I took the measurements with a ruler and on the example paper that you have. Of course, mine will be a little bit different on the board. So step one, to do a reflection, what we're going to do is make helper lines. And let's make the helper lines go all the way across, and you'll understand why later. So once again, just lining up your ruler such that a long division line is parallel to those lines of reflection. And we're going to go all the way across, so I'll just make it be like such. And then we're just going to make sure that we're parallel to that down here. Okay. All right. Next, I already measured out this distance, and this distance. So I'm just going to go parallel and that much beyond. So of course, mine are different. So for my A, it's 20.5. So I'll go right there. So that'll be my, and I'll go in blue. So it'll be A prime. And then for this one, it's like a 12 there and a 12 there. That'll be a C prime. And then once again, like a 12 there, like a 12 there. That'll be B prime. And again, you can use a ruler here. I'm just trying to speed things up. So that's the first reflection. Now what I want to do is reflect this about that line. And again, I've got the measurements in the paper there, so you can follow along. And now I'll go green. All right, so I'll just measure this. So I get like that. This one would be the same. So this is my B double prime. This is my C double prime. I'll measure this one over here. I get something like that. This would be my A double prime. And again, just connect the dots. Okay, so we have performed our double reflection across parallel lines. Now it's time to make an observation. Well, stepping back and taking a look, it looks like this and this are in the same orientation, so maybe it's just one single translation. Okay, and the next question is, well, in what direction and how far? Well, it seems to be going perpendicular to the parallel lines, and how far? Okay, so now what would be something interesting to do would be to measure the distance between lines M and N. So I already did that. I happen to have it memorized. So that distance is 4.5 centimeters from M to N. Then let's measure a distance from an original point to a final point. I think using B to B double prime would be the easiest. There's not so much in the way. So we'll measure from B to B double prime. And if you were to measure that distance, I did that, you would get 9 centimeters. Then, let's make an observation. This distance is 4.5 centimeters. That distance is 9 centimeters. It looks like it's twice as long. And you can easily prove that with the reflections. Okay, so now we'll fill in the blanks. The composition of two reflections across two parallel lines is equivalent to a single translation. Single translation. The translation vector is perpendicular to the parallel lines. And the length of the translation vector is twice the distance between the parallel lines. Twice the distance between the parallel lines. So there you have it, a double reflection across parallel lines and coming up with this general observation.